You have been a thorn in my side for far too long, Seer. Your 3D world will be crushed, terrain first, then the rest. I shall parade you before your loyal followers as the fallen idol of a pathetic Idalarialo. I banish you to the world of 2D. No one here knows of the depth buffer.
Hi, today we tile in 2 dimensions, isometrically, the pixel perfect way, or nearly so, using Godot 4. But before we start tiling, we need to create the tiles. And to create pixel perfect tiles, we need to choose the style. Let's take a small low-resolution cube as an example, using the first style. This is probably the most popular style, as you can find many tile sets of this type around. Uses a square frame and is very easy to draw or apply textures on each side. And it stacks well even when using highlights and outlines. But it appears a bit too slanted, and the edges are rounded in the center. The second style, on the other hand, is the one used by the 8th game in the Ultima series. A very nice looking pixelated retro game. This one also has a square frame, and is more accurate than the other one, although it has serious problems when stacking with highlights, because when the tiles are placed side by side, the highlighted points are not well covered. It's a shame, because this version looks better using so few pixels. But there is another option, the taller, rectangular version. It stacks well, but requires the tiles to overlap vertically by 1 pixel line. Since Godot can handle both styles, we can choose whichever one we find most comfortable. The first one does not require overlapping. It is undoubtedly the best, as we can see from the picture. The third one, on the other hand, would look like its buggy predecessor, except for a few differences on the floor. So, it is definitely the beauty. Obviously, we go for the latter. We can now create some sample tiles using tools like Blender and GIMP, but we could do the same job with Godot itself in a more automated way. For now, let's build a tile set made up of minimal cubes, applying highlights and outlines directly to the images without using shaders. This increases the number of tiles and memory used, but it simplifies things a lot. We're now creating the isometric image of a filled cube tile. In order to get the right image, we need to set the camera parameters and the cube's dimensions correctly. Otherwise, we might not get the desired style. Even using the beauty style, we need to slightly reduce the height of the cube to pursue pixel perfection, so it's not actually a true cube-like in 3D. We will create tiles with built-in shading, as was done in the past, but with Godot we could also use unshaded tiles and then dynamically light them during the game. We'll see that later. In Blender, pixel perfection is achieved by setting the closest interpolation in the texture mapping of materials, and increasing the contrast and resetting the film filter size in the output. The second cube will have a checker texture, after which we'll create a plano tile for the ground. This is just a simple tile set example to test out some techniques on Godot. But then we'll move on to something more interesting. Okay, finally the shape of a ground tile. Now we store the various border combinations for each tile within one or more images using GIMP. Since the border's appearance depends on the 3 neighboring tiles behind it, there will be 8 possible combinations, which can be reduced to 7 or 5 if some are identical. There are many ways to simplify drawing edges and reflections on different tiles. It's probably best to group wall tiles, floors, and objects separately by shape and size. Once we have built our tile images, we move on to Godot and use the super powerful tile map layer, which can do everything we need and more. The tile map layer requires a tile set. This can contain all the tiles and their associated data, such as the collision shape, the light occluder shape for dynamic shadows, the normal map for dynamic shading, and so on. In Godot, pixel perfection can be achieved using the Nearest filter for textures, vertex or transform snapping to pixel or both in viewports, and integer scale factors. A tile map layer instance handles only one horizontal tile plane. So if you need to display a 2-story house, you will have at least 2 tile map layer instances in the scene, where the topmost plane will always be drawn on top of the other, taking advantage of node order, z-index, or both. Well, the sample tiling is almost complete, but the shadows are missing. The great tiling masters of Ultima 8th didn't include them. Why? Since it's so simple in 3D, why shouldn't it be simple in 2D? With Godot we can cast shadows dynamically with a point light, or even better with a directional light. And we can create a normal map to get dynamic shading. Just put a blue on the left, red on the right, and lime on top, and that's it. But it won't work that easily in our case. The truth is that in 2D, shadows are inherently problematic and require a few tricks to make them look right. Let's see, for example, how to generate nice short shadows that do not work for a multi-level isometric game. First of all, we create a surface on which to cast shadows. For now, a sprite 2D will suffice, as it will only serve as a background. It doesn't matter which texture we use. Then we add an occlusion layer to the tile set, because with it we can assign a light occluder shape to each tile. This time, in order to cast shadows, we will use a well-known shader based on the signed distance field, SDF, so we have to enable it in the occlusion layer. Now we need a node which we can use as a shadow layer. A canvas group seems to be a good choice. I place a polygon 2D inside it to define the area where the shadows will be drawn. Once this is done, we can add the shader to the canvas group. Now we understand why this solution does not work. The tiles of the upper layer are shifted upwards, and with them the light occluders, and consequently the shadows. I have not yet found a solution that is worth using, because we must also consider that the shadows of the characters should be merged into this layer, if they are not completely opaque. Any suggestions are welcome. Therefore, for the time being, let us leave the shadows aside and focus on a beautiful tiling. Let's start again with Blender, producing an industrial set of texture-mapped tiles, and import them into Godot, building a sample scene. We have flat tiles for flooring, decorative tiles for grass, and walls divided into columns to give you more freedom in arranging them. In the scene tree, we have a parent node that sets the texture mapping filter for all layers, and a ton of layers, internal floor and external ground, at level 0, plants and walls at level 1, and finally, the walls on the second floor. It is not necessary to separate layers with the same z-index, because sorting based on the y-coordinate already solves all display problems, but only if the y-coordinate is that from the base of the tile. The tile set has been made like the previous one, with the only difference being that the tiles now have different dimensions. Nothing else changes. Don't forget the most important thing. Reduce the size of the main viewport in the project settings and let it expand by an integer scale factor. It also works with viewport containers and viewports within scenes. What are those things? Okay, it's all right. Don't panic. I think I know how to fix it. It's probably the texture padding. I just need to disable it and everything will work.
Yes, newcomer, seek a way out.
There's something odd here. But it should be even.
Even? Yes, even. It's a pixel alignment issue. We can fix the issue by translating the tile map layers by half a pixel, or better by replacing the tiles with ones whose height is an even number of pixels. Let's do it.
Hey! How badly you exist.
Don't. I can't do any better than that.
Go through the gate at the end of the road.
It worked. Thank you.
No worries.
Bye-bye.
Bye.
And this is how to align standalone sprites to the tiled world. The offset must take into account that the base of the displayed object is at the center of an isometric tile grid. Otherwise, sorting based on the y-coordinate will not work. That's all for now.